super dark. There we go. So we have 1, 2, 3, 4, 5 A's. And 2 4s. So 2 D's. 5 A's and 2 D's. Let's talk about how or why we got what we got. You guys like my pencil collection? So, will you flip the other light switch off next to you? Yeah, there we go. So it says, what property is being demonstrated in this equation? So we have 7, and then 11 minus 5, and then you get 7 and 6. So the associative property is the changing of grouping. Did my parentheses change? No. The multiplicative inverse is when you have a number like A, and you multiply by 1 over A. So I'm glad nobody had B, because it is not the multiplicative inverse. The commutative property is when you change the order. And again, we didn't change the order, so good job, guys. Nobody said C. And then my two fellows who said D with substitution, you would be correct. 11 minus 5 was substituted with the number 6. Okay, an example number 2. How many got A? Hold up a 1. 2, hold up B, or B, hold up 2. C, hold up 3. And 4. Okay, so I got 1, 2, 3, 4, 5. 5 A's. 1 B. Abby, I can't see your hand. Jacob, I can't see your hand. All right, thank you, Abby. Come on, Jacob, give me a 1, 2, 3, or 4. All right, so a majority of us picked 1. Now, did we pick 1 because it had the word 0 in it and there was a 0 in the problem? That's okay. It's a multiple choice problem, right? You used context clues to help you get the correct answer. A is correct. Okay, so today we are looking at the distributive property. We are looking at the distributive property. Our objective today is objective 1. We're going to evaluate expressions. So I don't know why your chart didn't print, but the table's on here. So it says John Burns approximately, and his name's not John Burns, it's that he burns, like as in the workout burns, approximately 420 calories per hour by surfing. The chart below shows the time he spent surfing in 1 week. So Monday he surfed for 1 hour, Tuesday a half hour, Wednesday not at all, Thursday an hour, Friday no hours, Saturday 2, and Sunday 2.5. So part A, how can you represent the time John spent surfing that week? What could I do to represent the time he spent surfing? Zoe? Perfect. We're going to add up all the numbers. How many hours did he spend surfing? Abby? Okay, so Abby got 9.5. Anybody else get 9.5? Sierra, I saw you on your calculator. What did you get? Guys, are we treating Tuesday like 5, not 0.5? Tuesday is 0.5. I know it's kind of hard to see. Let's try again. What do you get, Zoe? That's what I got. All right, by what number would I multiply to find the total number of calories burned? So I know he surfed for 7 hours. What number would I multiply the hours by to get total calories burned? All right, Sierra, your hand went up real quick. Perfect, 420. How can you represent the total number of calories burned as one quantity? How could I get that as a single number? What would I do? Perfect. So I'd multiply the 7 hours times the 420 calories per hour. I wish I burned 420 calories per hour. I could eat way more food then. What'd you get, Zoe? Perfect. What does that 2,940 represent? Does it represent hours? Days? Minute? What's it represent? Good? Perfect. Calories burned in 1 day, 2 days, 3 days, 10 days, 11 days. How many days? So sometimes the hardest part of a math problem isn't actually the math. It's knowing what that answer represents. So what is the total number of calories burned? It's 2,940 calories burned in 7 days. You could have also said in 1 week. Okay. So that leads us into our definition. So we're going to look at the definition of the distributive property today. The distributive property works with addition or subtraction. And what it says is that you can either have the number out in front or you can have the number multiplied to all the quantities inside. So the number can be out in front or multiplied to all the quantities inside. You guys should have a big or on your page where you write both of these down around it. Yay, nay. We all found it okay? I neighed like a horse. Only you get my jokes. Can I turn the slide, or is anybody still copying it down? You have 5 seconds to stop me. 5, 4, 3, 2, and going. Miss Nevaeh, you love to read. Do you want to read my word problem for me? His name's Julio. Remember, our textbook loves crazy names. Very nice. All right. So how many days does he walk? That's question 1. How many days does he walk? Luke, how many days does he walk? Awesome. Okay, Logan, how many minutes does he walk each day? So he does walk 2. Exactly. Perfect. So he does a quick walk for 7, and then he gets his heart rate really, really up. He's breathing hard, and he's like, oh my goodness, I need to walk for 2. So he walks really quick for 7 and slows down for 2. So what we're going to do is write an expression to show that. So to show the total number of minutes he walks each day. And there's 2 ways we could write this. We can write the total number of days he walks. And Logan kind of hinted at it. He said he walked for 7 and 2, or 9 in all. So one way to write it would be 5 days plus the total numbers of minutes each day. The second would be to say, okay, he walks fast for 7 minutes for 5 days. And he cools down for 2 minutes for 5 days. Either way you write that, you'll get the same number for how many minutes does he walk each week. Go ahead, Zoe. Oh, I didn't get 60. What's 7 plus 2? Let her fix it. She's got it. What's 7 plus 2? All right. 5 times 9. Yeah, there you go. So how many minutes does he walk each week? He walks 45 minutes per week. That's like nothing. You guys walk probably more than that in the hallways. Yes, Miss Abby. There you go, right here. 7 plus 2 becomes 9. And 5 times 9 becomes 45. Suzanne walks to school and home 5 days each week. She walks to school in 15 minutes and walks home in 10 minutes. So a lot of times when we have the distributive property, there's 2 ways you can always write it. You can write it where the number's outside and you're summing them inside. Or you can write it where you distribute the two together. So to rewrite this using the distributive property, I don't want you to add 15 and 10. I want you to distribute the 5. So that is one way to rewrite using the distributive property. So she spends 5 days at 15 minutes each day walking to school. So how many minutes in all does it take her to walk to school? Not in all, just to walk to school. So 5 times 15. Nobody? What's 5 times 15? Go ahead. 75. Perfect. So she takes 75 minutes each week to walk to school. Luke, how many minutes does it take her to walk home each week? Yep, 50. Or 5 times 10. So how many minutes does she spend walking in all? Sierra? Perfect. All right, so this is a little bit different because this time it's set up as a multiplication, but the idea would be to do this without a calculator. So if we're going to rewrite using the distributive property without a calculator, we're going to change the big number to be 2 smaller, like one big and one small number. So assuming no calculator, you're going to rewrite this to be 12 on the outside. And then instead of 82, I would make it 80 plus 2. So that you're multiplying 12 times 80 and 12 times 2. Now you're going to multiply these two together and these two together. And I'm sure for some of us, we'd still really like to use a calculator for 12 times 80. So 8 times 10, or 80 times 10, you would kind of multiply those two numbers together and get 800. And then you do 80 times 2, which is 160. So 800 and 160 is 960, or you could use your calculator. And 12 times 2 is 24. Adding them both together, you get 984. Okay. We just did one. Anybody want to volunteer to rewrite the next one using our trick we just did? And I think they got it already. What would I do to make it simpler? Go ahead, Zoe. What do you think? Perfect. Then you distribute, so you get 7 times 40 and 7 times 9. Logan, what's 7 times 4? Not 40, just 4. What's 7 times 4? Perfect. So guess what, guys? 7 times 40 is 280. Exactly. You just add on that 0. Abby, what's 7 times 9? Perfect. All right, Jacob. Did you get a final answer? Not yet. So our final answer would be 280 plus 63. So again, if you don't want to say it, can you just show me on your hands or fingers what those numbers, what first digit would be? So what's my 100 digit? Remember, Mr. Mannion has calculators. If you want a calculator, we can give you a calculator. Patient, guys, it's okay. Anybody need a calculator? You want to give me your answer, don't you? Go ahead. Okay. 3, 4, 3. I love numbers that are the same forwards and backwards. Yes, palindromes. This is your last one, right? No? There's 2 more? Alright, I couldn't remember. Okay, so guys, guess what? You don't always have to rewrite the second number. Multiplication is what property? It is, what's it called if I take 304 times 15 and rewrite it as 15 times 304? What's that called? We learned it last week. Starts with a C. Good. Commutative. Fantastic. Whoopsies. Apparently I can't spell today either. Now let's rewrite this. Who thinks they have the rewriting? We got 1. We got 2. Anybody else think they know how to rewrite it? Show me your hand up. We got Abby. We got Mr. Lyle. Nevaeh, you don't know? Okay, Sierra, I haven't heard from you in a while. What did you get? Oh, you're so close. What's she missing then? Instead of a 30, Abby, what should it be? Yeah, you lost a 0 on me. All right, guys, what's 15 times 3? Abby? Oh, what'd you get? Go ahead. Yeah, it's 45, right? So if 15 times 3 is 45, 15 times 300 becomes what, Abby? Yeah, we missed another 0, didn't we? Yeah, it's 4,500. All right, so 15 times 3 is 45. 15 times 4, Zoe? Perfect. All right, and Logan, what's my final answer? Jacob, make sure you're copying it down, honey. Perfect. All right, Luke, I haven't picked on you in a while. How could I rewrite this? All right, I heard the 5 plus 200, and then I couldn't hear anything else. Perfect. So he said, he actually even gave me the next line. He said 5 times 200 plus 5 times 10. Go ahead. What'd you get? Final answer, 1,050. Because 5 times 2 is 10. Add some zeros. 5 times 10 is 50. We get 1,000 plus 50 is 1,050. Guess what time it is? Homework.